So looking at these binomial probability distributions, you've already looked at it on Kognity, okay? But I want to just address a couple of things because there's some really common problems that students have with this. And I also want to point out a couple of things related to like the IB exam and problems, that type. First of all, it's just understanding when you're supposed to use the binomial probability theorem. And the idea is when you are repeating something over and over again, and that those repetitions are independent, okay? Now you can see some examples: flipping a coin, rolling a die, selecting someone and then replacing them. So like if I were to pick one of you 9 at random, and then I picked another one of you 9 at random, but I was allowing myself to pick the same person both times, that would be with replacement. Okay, so those would be independent events. If I picked one of you and then my second person I was picking out of the remaining 8, that would not be this case. Okay, the last one here is the most easy to overlook. And that is when you're given a statistic about a population. And an example I used was, and this is totally made up, okay, but let's suppose that we found a statistic that said only 20% of adults get enough sleep. Okay? We don't know how many adults are out there. It's just a random statistic. So if we pick someone, even if we don't allow for ourselves to pick the same person again, that population is so huge that removing that one, regardless of whether they do or don't get enough sleep, is not going to impact the statistic or the likelihood of getting someone the next time, okay? If you take one person out of, 100 million, that's not going to impact that 20% at all, okay? So we can treat that as a independent event, right? Now, there are a couple of things. This is just review stuff that you should have already looked at. Notice the formulas down here at the bottom. The mean and standard deviation are given in your formula booklet. I don't believe the variance is, but you guys should know variance is just standard deviation squared. So you can figure that out, okay? The thing I want to focus on here is using the calculator, okay? Using the calculator. Now, here's our scenario. If 20% of people get enough sleep and you survey 20 people, okay, that picking 20 people is the repeated event, okay? So thinking back to what we know about binomial situations, notice the number of people we picked is right here, the 20 people. This is the probability of finding someone who does get enough sleep, which means we have an 80% chance of finding someone who does not get enough sleep. Okay? So, I want to look first of all at the probability of getting X number of trials. Now that's just a fancy way of saying, in this case, what's the probability of getting exactly a certain number of people who get enough sleep? So we're going to say, what's the probability of finding exactly 7 out of those 20 who get enough sleep? All right? Well, let's work through that using the theorem first of all, and then let's look at using the calculator, okay? According to the binomial theorem, the probability of getting exactly 7 is going to be 20 choose 7 times 0.2 to the 7th, because we want 7 of the people who do get enough sleep, times 0.8 to the what power? 13th power. These have to add up to 20. And notice here, we have 7 people who do get enough sleep, we get 13 people who do not get enough sleep. And then we multiply by the binomial coefficient. Okay? That's how you would do this. But the nice thing is your calculator actually has a nice built-in function called binomial PDF. Okay? Now you can see it right here. The way you get to it is by going to distributions. That's second vars on your calculator. Okay? You hit second and then the variables button. You see DISTR distributions and scroll down to A, and that is the binomial PDF. Now notice there's also a binomial CDF, and we'll talk about that in a second. Okay?
The trials would be 20.
Okay? Yeah, now notice here it calls for N, P, and X. And on the 84, those of you who have the 84, it brings up this nice little menu you see here on the left. The number of trials is how many times we're repeating it. So that's our 20 up here. We're asking 20 people. Then P is the probability of getting what we want. We want someone who actually gets enough sleep, so P is 0.2. And then the X value is how many people we want to fall into this category. We want 7 to have enough sleep. Okay?
Wait, how did we get 7 again?
We just picked that out of the air.
Oh, okay. That's the
We could have done, what's the probability of getting 12 of them? Or what's the probability of getting 3 of them? So, we just picked 7. Alright, so in the calculator, what you're going to see after you type this in, and actually if you have the 83, you're going to have to remember how to type this in because it doesn't give you the little menus. You're going to see binomial PDF parentheses, and then you're going to see 20, comma, 0.2, comma, 7. Okay? And that gives you what?
5%.
Well, let's use 3 significant figures. 0.05, 4, 5. 3 significant figures. Okay? Did you use CDF on accident?
No.
Binomial PDF, and you did 20, 0.2, and 7. Oh, you picked normal PDF.
Oh, I did that too.
Yeah,
Yeah,
make
Scroll all the
sure.
way down.
Scroll down to A is binomial PDF. Normal we're going to look at next week. That's the normal distribution. That's a totally different distribution. Okay? Okay, so does that make sense?
Yes.
All right? Not too bad using the calculator there. Where it gets challenging is when we're asked to find the probability of a range of values. Okay? So, for example, if I wanted the probability of getting no more than 7 people who got enough sleep. All right? If that were the question, I would use the binomial CDF. Now, PDF stands for probability density function. CDF stands for cumulative density function. Okay? So it's cumulative. That means when I do CDF here, this is going to give me the probability of 0 plus the probability of 1 plus the probability of 2 plus all the way up to the probability of 7. Okay? Now this is really nice because we don't have to do 8 different problems here and simplify them all. We can use our calculator and we would do binomial CDF, and you put in N, which again is 20, P, which is still 0.2, and X, which is 7 again. But now it's not giving us exactly 7, it's giving us 0, 1, 2, 3, 4, 5, 6, and 7. All added up. Okay? Does that make sense? That's what the binomial CDF does. Okay? Now, follow-up question. What's the probability that x is more than 7? What's the probability we find more than 7 people who are getting enough sleep? There we go. We got to use the complement there. We would do 1 minus the probability that you got x less than or equal to 7. Okay? So, did anyone actually do that binomial CDF of up to 7? What'd you get there, Murat?
0.968.
0.968. So now if we subtract that, we get a 0.032, right? Okay. So the probability of finding more than 7 people, 8 up to all 20, is only 3.2%.
I got a different answer than 0.968.
Did you use binomial CDF?
Yeah. Oh, never mind. I made a mistake.
Okay, that's okay. That's why all of you've got to get your calculators out and be doing this, because you gotta get used to working with this.
Yeah.
Is it,
Yes.
It's binomial CDF? Or,
Correct.
okay, because I keep getting, so I do second bars, and then go down to B.
Yes.
And then type in 20. And then the p-value's 0.2.
Mm-hmm.
And then the x value is 7, and it's saying that there's an error.
Did you do 0.2 or 2?
0.2.
Okay, now, those two aren't too bad. Where it can get tricky, and they actually learned when they built the TI Nspire, and they built in extra functionality into this binomial CDF. In the Nspire, you can put an x and a y in there, and it'll do the probability of between this and this, inclusive. The 83 and 84 do not do that. When you do binomial CDF, it will always give you from 0 up to whatever you want. So there's two ways of handling this. Let's say that I wanted the probability of getting between 3 and 7 inclusive. So I wanted the probability of 3 or 4 or 5 or 6 or 7. Okay? Two ways you can handle this. Again, what we're doing is probability of 3 plus probability of 4 plus probability of 5 plus probability of 6 plus probability of 7. Now I write that out for a reason, okay? If you want to use the CDF function, all right, you can do it. You would do binomial CDF with 20, 0.2, and 7. However, you got too much, right?
Oh, so you can subtract it from
The CDF.
the 20, 0.2, and 2.
Yes, and the tricky part is making sure you get the right boundary. You would subtract binomial CDF of 20, 0.2, and not 3. That's what people mess up.
Because 3 is included in
We want to keep the 3. We only want to subtract 0, 1, and 2. Okay? So that's one way of doing it. And if you've got the TI-83, that's the way you're going to need to do it.
What about 84?
The 84, the sigma notation is actually not too bad. The 83, the sigma notation is so convoluted it's not even worth using. Okay? You're better off just going with this. The option, you can see up here, the option is to go back to using binomial PDF in a summation.
Oh.
Okay? And I'll tell you about this, and then I'll actually show you on the calculator here so you can see it for yourself. All right? The other way of doing this would be to do the sum from x equals 3 to 7 of binomial PDF with 20.2, and then watch this, x.
X?
Because we want to do it once when x is 3, then once when x is 4, then once when x is 5, and then 6, and then 7, and the sum will add them all up together. Okay? It sounds complicated. Let me show you on the calculator, though, how it works. And it's really not terrible. Okay? And whether you use the subtraction method or the summation method, I don't care. I just wanted to show you both. So let me do this. We'll insert a video here.
Wait, Mr. Rickson, the answers came out to be slightly different. Like, actually, it's rounded.
Okay, it's rounded. All right, so let's. Why is this? Oh, there we go. Find my calculator. All right. Okay, so we're going to do the probability that we get between 3 and 7 people who get enough sleep. Okay, so I'm going to clear this. Under math, first of all, is your sigma notation. Okay, math, go down to 0, and you get your summation. Now here's again where the 84 is really nice. It gives you this little menu, okay, or this little like template to fill in. The 83 is a real pain to use. Don't even bother, because you'll never remember like the order to put everything in. So what we're going to do is we're going to do x equals 3 to 7. Whoop. 3 to 7. And what am I adding? I'm adding the binomial PDF at each value. So I go to second variables, that's the distribution, and I'm scrolling down
PDF?
to PDF, yes. Now, I have 20 trials. I have a 20% chance of finding someone who actually does get enough sleep. And then I'm going to put in X for that. That's important. Okay? Then I hit enter, and you can see there it put that in my sum. And we should get a 0.762 if we round to 3 significant figures. Okay?
Wait, what is it? 20.2 and x?
Yes, 20.2 and X.
Mr. Hickson. So the other way would be subtracting the both CDF, and this one is the summation of the PDF.
Correct. Yeah, so you got to think of it, you know, the subtraction method is basically kind of like this. You're, you know, you've got 0, 1, 2, 3, 4, 5, 6, 7, and so on. So the binomial CDF up to 7 includes all of this. The binomial CDF up to 2 cuts this part off, so you only get the piece you want. All right? The summation notation just calculates each one separately and adds just the ones that you need. So really, this is just a matter of preference. Whichever way makes sense to you, go with it. Okay?